Okay, so today we are doing 5.4. This one is dividing fractions. Very similar to 5.3 where we multiplied our fractions. You just have one step that you have to do before you can do multiply, basically. So kind of like when we were dealing with polynomials, or we've kind of talked about it other times, we can change subtraction to addition by adding the opposite. So we changed an operation to a different operation that we wanted to use. You do the same idea, or kind of the same kind of thing with dividing fractions. So we don't like to divide fractions. We instead say we're going to multiply by the reciprocal. So remember, once you've changed the operation, remember I talked about you change the operation and then you change the stuff that follows the operation that you've changed. You don't touch the stuff in front. Let me show you. So, if I'm dividing fractions, hold on just a minute, let me get to my right paper. I didn't have it opened. Okay. Sorry. So if we had, let's do 5/8 divided by 2/3. So again, I'm going to change this operation. I don't want to divide when I have fractions. I want to change it to multiply, because multiply is really easy, right? You multiply straight across. Multiply is also the inverse. That's why it kind of is paired with the division. But if I change that operator to multiply, I'm going to do a dot to represent multiply on this one. Once you've changed that, you have to change the stuff that follows that. You leave the stuff in front alone, and then you change the operation from, let me write up here what we had. We had 5/8 divided by 2/3. And I didn't want to divide, so I changed it to multiply. But I can't just leave it as 2/3, because then it's just changing the operation. That would be kind of silly. It's not going to be the same. So if you change the operator, you've got to do something to the following number, following fraction, which is, we call it times by the reciprocal. This reciprocal is where you just flip. Let me show you what I do with my fingers. You just flip them. So they just change spots. So your numerator becomes your denominator, and your denominator becomes your numerator. So instead of 2/3 like we had before, we will have 3 halves, or 3/2. So notice I just switched these places. You don't switch the first number. We had 5/8, we stay with 5/8. Operators changed, and then these changed. So we say we times by the reciprocal. This is called the reciprocal. So a reciprocal, I'll do a different color. We'll do it over here on the side. So if I have 1/3, the reciprocal is 3/1. If I have 26/41, the reciprocal is 41/26. Okay, we're not doing anything with this, like I'm not multiplying or adding these guys together. All I'm trying to show you is what a reciprocal is. So when we say we change fractions, we change the division to multiplication, and we change it to timesing by the reciprocal. What I mean by reciprocal, that's just a vocabulary word, is the flip of the fraction. Okay, so these guys are all reciprocals of each other. This is a reciprocal of that, and this is the reciprocal of that. Okay? Let's show you what we do after we do that. So this was our original problem up here. I had 5/8 divided by 2/3. Didn't want to divide. I changed it to times by the reciprocal. And now it's just multiplication. This is just the lesson from last time. You multiply straight across. Multiply your numerators, and you get 15. Multiply your denominators, and you get 16. Is there anything that will go into 15 that will also go into 16? 15, you're choices are 3, 5, and 15. 3, 5, and 15 will not go into 16, so you are reduced. So you're done. It's really that simple. But of course, there's lots of other little situations and stuff that we're going to talk about. But that is the whole idea of how to divide fractions. So here's an example of a scenario that looks a little different. So we're going to do a negative 7/12 divided by negative 14. Okay, so immediately I notice I've got fractions and divisions. So I go, oh, I have fractions and I don't want to divide. So what can I do? I'm going to change it to times by the reciprocal. Well, this isn't a fraction, but it is. Remember, anything is over 1. So I'm going to change this. You leave the first fraction the same. I'm going to change that to multiply and then flip it. The negative, I'm going to keep it down with the 14 since in this problem it looks like it's with the 14. But again, it doesn't matter. If you've got a negative, overall this is a negative number times a negative. Negative times a negative is a positive. So your signs are just a matter of thinking them through. So I know I'm going to have a positive, so I'm not even going to look at the signs. Now it's multiplication, so I just time straight across. 7 times 1 is 7. 12 times 14. That one's a little trickier. You might need to go, let me see if I can see me. 14 times 12, do it on the side. 4 times 2 is 8. 2 times 1 is 2. 1 times 4, and 1 times 1. Add them together, 8, 6, and 1. So down here we get 168. 7 over 168. Okay, is it reduced? I don't know. So you've got to figure out, would something go into 7 that will also go into 168? Well, the only thing that will go into 7 is 7. So you have to see if 168 is divisible by 7. Okay, so 7 goes into 16 2 times. 2 times 7 is 14. Subtract and bring down. 7 goes into 28 4 times. 4 times 7 is 28. So it did go into it evenly. So 7 would go into 168 24 times. So that means if I divide this top by 7, I'm just reducing my fraction, and divide the bottom. So you have, whatever you do to the top, you have to do the exact same thing to the bottom. Divide both of them by 7. I'm going to erase this. 7 divided by 7 is 1. 168 divided by 7, we just did that, is 24. Okay, so there is our final answer for negative 7/12 divided by a negative 14. We ended up getting our 1 over 24. Okay, now back to just review. Side note, if you get this, stick with it. Somebody I'm sure is probably thinking about canceling. Because this was multiplication, you could have, I have a 7 that I could pull out up there, and a 7 that I could pull out of the denominator, out of the numerator and denominator. And then I would have ended up with 2 times 12 and gotten my 24 that way. If that doesn't make sense, don't worry about it, because I just taught you how to do it. And again, I don't like the cross-canceling stuff, because people go cross-cancel crazy. And then when we get into addition and subtraction, they mess up. So it's safer just to multiply straight across and reduce. Once you have that, you'll get all of the problems right every single time if you do it correctly, as always. Okay, let's look at a different looking problem. Same idea, but this time we're going to do 9/10 divided by, so this is all written vertically, 21/10. Okay? Now most people look at that and they just don't even know where to start. But if you remember these signs in our fraction are just another way of writing division. So I made that one more bold, so hopefully it would stand out that this is a fraction divided by this fraction. So if you wanted, you could rewrite it, which is what I would suggest. You write it horizontally instead of vertically. So I've got 9/10 divided by 21/10. And then I approach it just like we did the other one. So I say, oh, I don't like 9/10 divided by 21/10. I want to multiply, so I change it to 9/10 multiplied by the reciprocal. So 10/21. Okay. This might be an easy one for those of you that understand the cross-cancel thing to cancel with, because you have a 10 upstairs and a 10 downstairs. Notice I can only do that now. I didn't even consider it and look at it when I was looking at the division problem. You cannot do it unless it's multiplication. Okay, so I cancel my 10s, and then I'd be left with 9/21. Or if you know a 3 comes out of both of those, you can reduce it even further. Let's just multiply and not do the canceling stuff, though. Multiply fractions, you multiply your numerators, then you multiply your denominators. So I get 9 times 10 is 90. 21 times 10 is 210. Got to reduce that fraction. I'm going to come down here. So 90 over 210. Okay. Remember the trick. If the zeros are at the end, I can cancel 1 for 1. So I've got 9/21. Essentially, all I did was divide both of those by 10. And then I go, oh, I know 3 is a multiple of 9 and, or a factor of 9 and 21, so I'm going to divide 3 out of both of those. 9 divided by 3 is 3. 21 divided by 3 is 7. And there is your final answer. Doesn't reduce anymore because 3 won't go into 7. Okay. Let's look at some problems with mixed numbers. Okay, I kind of talked about this in the 5.3 video, but when you are working with mixed numbers, it's just so much easier if you'll just change them to improper fractions first. And we'll talk about and review how to change them. Okay, so let's do 4 2/9 divided by -8 1/3. Okay. Remember, when you're multiplying, or not multiplying, converting from mixed numbers to improper, you multiply your whole number times your denominator and throw it in the top. 4 times 9 is 36. Add it to the top. So we get 38, and you keep the denominator. Remember, we didn't change the size the pieces were cut into, so it stays 9. Divided by, I'm just going to keep writing everything else we have. Put our negative. Remember, when you're changing mixed numbers, ignore that negative. Don't include that. Okay, that's just saying I've got a negative, whatever this is. So I've got to figure out what this is. 8 times 3 is 24, plus 1 is 25. And it's over 3, because that's my denominator. And now it's just a problem like what we have been working on. So instead of doing multiplication, I'm going to change, so everything's the same, but I'm going to change the operation to multiplication, or sorry, instead of doing division, I said division, or multiplication. Instead of doing division, we want to change it to multiply by the reciprocal. I'll say it a million times so you can get it in your head. Multiply by the reciprocal. And hopefully when you hear the word reciprocal, you picture flipping. Okay. So now we're down to multiply, and I've got a positive times a negative, which means I will end up with a negative. And that's all we worry about with the signs. We don't take those into consideration other than just that, because you're multiplying. Now I need to do a 38 times 3 and a 9 times 24, or 25, wow. So I'm going to do those to the side. If you notice about canceling, go ahead with that if you're comfortable with that. 3 times 8 is 24. 3 times 3 is 9 plus 2 is 11. So I get 114 over, okay, I've got 9 times 25. I'll do that over here to the side. 25 times 9. 9 times 5 is 45. 2 times 9 is 18, plus 4 is 22. So I end up with 225. Okay? Oh, let me see. Sorry, I'm trying to make it so you can see everything we've done, but I don't know that I can get it all there. Okay. So now we just need to look and see if there's something that will go into both our numerator and our denominator so we can reduce. They're not even. Let me try to get you closer. They're not even. They're not both even. This one is, but this one's not. They both don't end in a 5, so we can't do any of those tricks. Best tricks to try on larger numbers are the 3 and 9, so we're going to add all the digits. So 1 plus 1 is 2, plus 4 is 6. Oh, 6 is divisible by 3, so 3 goes into that one. Let's see if 3 will go into this one. 2 plus 2 is 4, plus 5 is 9. So yes, 3 will go into the top and the bottom. So I'm going to divide this one by 3 and divide this one by 3. Okay, those are just things you have to do out to the side. So I'll work that up here. So I'm doing 114 divided by 3. 3 will go into 11 3 times. 3 times 3 is 9. Subtract. I'm going to have to borrow. I get a 2 and bring down. 3 goes into 24 8 times. 8 times 3 is 24. And we're done. So I get 38. So this 114 divided by 3 is 38. So I'm going to write that down below. Let's see where you can see. So my answer was a negative, if you remember. And I got 38 for my numerator when I divided the 3 into it. And now I need to do 225 divided by 3. So I'll do that. I'll erase that one. 225 divided by 3. 3 goes into 22 7 times. 7 times 3 is 21. Subtract and then bring down your 5. 3 goes into 15 5 times. 5 times 3 is 15. Subtract. Okay, so it went 75 times. So 225 divided by 3 is 75. Okay, and you can try your tricks again to make sure you're reduced all the way. They're not even. The 5 rule won't work. If I add 8 and 3, I get 11, so that's not divisible by 3 or 9. The only other options are probably like 7 or 11, but I happen to know that 7 will not go into 38 evenly because I know the multiples of 7. And 11 is not going to go into 38 evenly because I know the multiples of 11. 13 is one that might catch you off guard, or can sneak in there, but I know 13 is not going to go into 38 evenly. But if you don't know that, you're just going to have to divide it out and try it separately. Okay, so there is how to do 4 2/9 divided by -8 1/3. So we changed it to improper, then changed it to multiply by the reciprocal. We multiplied straight across, and then we just reduced. So basically, this is kind of a review of the last two videos. Reducing, this was 5.2, reducing fractions. Multiplying fractions is 5.3. And then today we did 5.4, which is what to do when you have division. So it's kind of just combining everything all together. Okay. Oh, and this was 5.1, converting mixed numbers to improper fractions. We did that on Thursday in class. Okay, let's try some with variables. Erase my whiteboard. I'm a little nervous though. My kids think now that they can draw on stuff, so I'm nervous they're going to whip out the Sharpies and start drawing on my washer. Okay, so let's do some with fractions, or excuse me, with variables. So if I have 7, 15x, 7 over 15x divided by 1 over 6x to the third. Okay, so you're not going to treat it any differently than the problems we've been working with variables and multiplying. So 7 over 15x, we don't change that. We just change our division to times by the reciprocal. So 6x to the third over 1. Oh, sorry. Don't know if you could see that. Okay, then I multiply straight across. Multiply my coefficients. 7 times 6 is 42. No x's over here, so my x to the third doesn't change. I didn't multiply the x's by any more. Okay, now I look at the denominators. 15x times 1. Anything times 1 stays the same. So it's just going to be 15x. Okay, now you need to reduce your fractions. So what will go into 15 that will also go into 42? I happen to know that 3 will. So I'm going to divide 3 into 42. And I end up getting 14. You can do that out to the side if you don't know. And divide 3 into 15 and I get 5. I just happen to know that it would go into it. You could do the trick. 4 plus 2 is 6. 1 plus 5 is 6. 3 goes into 6. So you know 3 will go into both of them. Okay. And then with your x's, if I have 3 upstairs, remember it looks like this. X, X, X. They're timesing each other. And down below I have 1x. So these guys are going to make one whole. So they're gone. So that leaves me with x times x upstairs. So I'm left with x squared. So eventually you'll get really comfortable with this and it's super easy. So as soon as you see x to the third over x, you're just like, oh, this is going to wipe out one of these up here, leaving me with just 2 up there. So squared. And this is gone. And so then you have your, reduce that 14 over 5, and then my x squared. So there is your final answer. If it wants it in mixed number form, that's fine. It will tell you as such, but in our assignment, they don't. You can just leave them as improper. It gets a little more complicated when you have the variables and mixed numbers. So that's nice that we can just leave it. Okay. Let's do maybe one more with more variables and we'll call it good with that part. Okay, how about t squared times u to the fourth over 18v to the third divided by a negative 10 t to the fifth over 12v. Okay. First thing, fractions and division. Don't do it. So I change to times by the reciprocal. So I write the first fraction the same, then times by the reciprocal. So 12v goes on top, and negative 10v t to the fifth goes on bottom. And now you just multiply straight across. So coefficients, I've got essentially a 1 here, right? 1 times 12 is just 12. And then t squared times u to the fourth times v. None of those variables are the same, so my exponents don't change ever. So I'm just going to have t squared u to the fourth times v. Right? That was just written out. T times u times u times u times u. I think that was 4 times v. And then we use the exponents to just write it without writing them all out repeated. Okay, down here, 18 times negative 10 is a negative 180. Then my v to the third times t to the fifth. Again, they're not the same variables, so it's just v to the third times t to the fifth. Okay, so there's our fraction we need to reduce. So we have 12 and 180. What would go into both of those evenly? 4 and I believe 12 will go into, yes, it will. So 12 will go into 180 evenly. Again, if you don't know and you can't think it through, you can do the prime factorizations that we did, or you could just chisel it down where they're both even, divide 2 out. If you know 3 would go into 18 and 12, then you know 3 will. You could divide 3 out. Maybe you know, or you figured out that 4 would, or 6 would, because 6 goes into 12 and also into 18. I'm going to do 12 since I know we can, and this lesson's more about multiplying or dividing the fractions, not simplifying. Okay, so 12 divided by 12 is 1. I'll deal with the variables in a minute. Negative 180 divided by 12 is going to be a negative 115. And now let's work on the variables. So if you don't want to write the 1 upstairs, you don't have to, as long as there's something else holding the spot up there. So if all our variables canceled off, then you would need a 1. But as long as there's something up there, you don't have to have the 1. So if you don't want to write it, that's fine. Okay, so now I'm going to look at my variables. So I've got 2 t's, t times t upstairs, and downstairs I've got 5. So I'm going to take those 2 and cancel them with 2 of them that are downstairs. So that's going to leave me with 3, t to the third downstairs. Okay, my v's, I've got 1 upstairs and 3 downstairs. So I'm going to take that 1 and cancel it with 1 downstairs. So instead of 3 now, I only have 2. And the u's, I don't have any downstairs or in my denominator to cancel with it. So I'm left with u to the 4th in the numerator. And in the denominator, I've got v squared and t to the 3rd. So write v squared, oh, I don't know if you can see what I'm writing, v squared times t to the 3rd. And that is totally reduced because there's nothing upstairs that would cancel with anything downstairs. Our coefficients are totally reduced. So we're done. So that's how you would do it with more variables. I'm going to change something really quick just because I want you to see. So I'm going to keep the same problem. I'm just going to change some of the variables. So I want to change my u to a v. Okay, so down here, this was a v, or is going to be a v now. Okay, so this all stayed the same, changed it to times by the reciprocal. Okay, so all I wanted to show you is when you're multiplying straight across, again, 1 times 12 is going to be 12, or there's nothing to times by it, so it stays 12. And then t squared, no other t's, so it stays t squared. I'm just looking at the numerators. Don't look at the denominators right now. We're just multiplying straight across. Now I've got 4 v's multiplying by each other, and now I'm going to times another v into that mix. So I've got v times v times v times v times v. So I have v to the 5th. And down here, I don't have negative 180 when I do the 10 times, negative 10 times 18. And I don't have any variables multiplying by each other from one fraction to the other, so it's not increasing my variables. So it's just going to be b to the 3rd times t to the 5th. And now you do the same as we did before. You reduce the coefficients, and then I've got 3 v's downstairs that will cancel with 3 upstairs, leaving me with 2. And I have 2 upstairs of the t's that will cancel with 2 downstairs, leaving me with 3. So I'd be left with this reduced, we know, is 1 over negative 15, because we just did that. And this left me with v squared and t to the 3rd. Okay, so again, if you don't want to write that one, since there's something upstairs already to hold it, hold the spot, then you can just erase that if you wish. Okay, so I just wanted to show that the exponents can change. You're not always going to be just keeping the same variables that you had. Okay, that's it for variables. We still have another couple pieces, so hang on. We're going to talk about square roots and then solving for x's, or variables, sorry, not just x's. So if I have a square root of 64 over 81, okay, now we're doing square root of fractions. We've done square roots before where I had, say, the square root of 25. Remember, it's whatever it takes to make this number multiplying by itself. What did I multiply by itself to make 25? Is a better way to say it, sorry. So 5 times 5 gives me 25. So the square root of 25 then is 5. Remember that? So same kind of idea when you have it in fraction form. It's the same as breaking it apart. If you have the square root of a fraction, you can write it as the square root of the top over the square root of the bottom. So the square root of the numerator over the square root of the denominator. And now we go, oh, I know what the square root of 64 is. That's 8. And I know the square root of 81. That's 9. And you're done. That's it. It's really that easy. There will be a few problems that aren't quite as straightforward. I'll show you one. And what I mean by that is if I've got the square root of 960 over 15, remember I just told you that you can just do the square root of the numerator and the square root of the denominator. Well, I'm getting a little bit of a red flag because the square root of 15 is not a pretty number. And remember I told you right now with square roots we're just dealing with pretty numbers. So that tells me that I need to divide first. So sometimes it's easier to apply the square root to the numerator and the denominator and get your answers. And sometimes it's easier to divide first and then take the square root. The nice thing is we're still going to get the same numerical value, so it doesn't change the integrity of the problem when you do that, if you choose to do division first or apply the square root to the top or the bottom first. Okay, so we're going to divide. I don't know what this one is off the top of my head, so we just work it out. So we have 960 divided by 15. 15 goes into 9, it won't. 15 goes into 96, it will. How many can I pull out? So I think the best way to kind of approach this or think through it is to just pair up your 15s, because if I take two 15s, it makes 30. So two 15s would be 30, two more 15s would be 60, and two more would be 90. So I end up with 6. If you're thinking that through and that doesn't work for you, then maybe try a different approach. I know some of you just try attempting, or you'll multiply out to the side. That works too. Whatever it takes for you to think it through. Another approach could be, what do I multiply 5 by, and add the first number, the first digit, to whatever I'm multiplying here. That might be really confusing to make this number. Okay, so a few options. Let's just continue with our division. Since we're not teaching division, hopefully you learned that a long time ago. Day 1, I think we did division. Maybe day 2. Okay, 6 times 5 is 30. Carry my 3. 6 times 1 is 6. Plus my 3 makes 9. And then I subtract, and then I bring down. Now I look at this number. How many times, I'm going to erase what I carried. How many times will 15 go into 60? We just talked about that. It goes 4 times. Oops, sorry. 4 times 5 is 20. Carry your 2. 4 times 1 is 4, plus 2 makes 6. Subtract. And you're done, because there's nothing else to bring down. So 64, so all of this, 960 divided by 15 is 64. But I still haven't done the square root, so I can't get rid of that. I have to write that until I've thought, what is the square root of something? Okay, and now we're ready to do that. What is the square root of 64? 8. And you're done. Okay, so those are pretty easy. Last thing we need to talk about is how to solve for a variable when you have fractions. This one tends to throw people a little bit. I don't know, I kind of find that people pick up on it or they don't. They struggle a little bit. So what I'm going to suggest is kind of like a math for dummies rule, meaning just I'm not going to explain why in the beginning. I will explain on this video. But I'm not going to explain why. I'm just going to show you what to do. A quick, easy way to do it. So anytime you look, so we get down to the point where we've got a coefficient and the variable equals number. So basically we have variable term equals number term, right? From this point I go, oh, I'm multiplying, so I want to divide, right? But when your coefficient is a fraction, what I want you to do is times both sides by the reciprocal of that coefficient. And it has to be the coefficient, meaning it has to be multiplying by the variable. If this is the fraction and this is a whole number, I'm not talking about that. I'm talking about when this number right next to the variable is a fraction. So remember, the reciprocal is just the flip. So I'm going to times this side by 4/3. And if I do it to one side of my fraction, I have to do the exact same thing to the other side. So I'm going to times this side by 4/3. Okay? Now, if you're familiar or comfortable with the whole canceling thing when we're multiplying, remember I'm multiplying this, then you might notice 4 is upstairs and a 4 is downstairs, a 3 is upstairs and a 3 is downstairs. Those will cancel each other out. If you're not comfortable with that, then you'll just multiply. 4 times, when I multiply fractions, you just go straight across. Remember, 4 times 3 is 12. 3 times 4 is 12. And I have my x equals, and we'll multiply this side. Remember, this is over 1. 12 times 4 is 48. 1 times 3 is 3. Notice I ended up with 12 over 12 over here, which is 1 whole, right? So 1 times anything stays anything. So essentially these cancel each other out is what we say. And so we're just left with our x. Okay, so x equals 48/3, which is what we're looking for, is just getting a number for x. But I need to check and see if this reduces. Remember, reduce, reduce, reduce. And it will, because 4 plus 8 is 12. 3 will go into 12. And 3 will also go into 3. Or maybe you just already know that 3 would go into 48. So we're going to reduce this fraction by 3. So we divide both the top and the bottom by 3. So I get x equals, 3 goes into 4 once, leaving me with, if I subtract 3 from 4, I get 1. And then bring down my 8, so that I would have 18. So then 3 times 6, it would be my 18. If you can't do that in your head, which I wouldn't expect many to be able to do, but for those that can, that's great to talk about mental math. 3 goes into 4 once. 1 times 3 is 3. Subtract and bring down. 3 goes into 18 6 times. 6 times 3 is 18. And we get a 0. Okay? And then 3 divided by 3 is 1. So again, you don't have to write it when it's by itself in the denominator. So x equals 16. I'm just going to rewrite it so it's next to my equal sign. Okay? So here's the trick. When I have a fraction coefficient, I don't even write this part, because you can skip that step because you know it's going to end up canceling each other out. So I just go like this. If I were to do this problem, I'm going to do it from the beginning. This is how I think about it. I'm going to multiply both sides by the reciprocal because my coefficient is a fraction. So once I multiply, that's gone. So I'm going to get x equals 12 times the reciprocal is 4/3. And then I just do that, and I get x equals 48 over 3. Reduce that, and we just did that, so I know that's 16. There's going to be 16. Okay? So the quick, easy step is if you see a coefficient for the variable is a fraction, then times the other side by that reciprocal. And then it essentially will go away over here, so you don't even need to worry about that side. Let's try another one. We're going to do two different ones. Let's do this one with the negative. Okay, so I'm to the point where I've got number term, equal sign, variable term. So I want to get this coefficient away from my x. It's multiplication, so I think, oh, divide, but no, I'm not going to do that. Okay, I want to, remember my quick step, I go coefficients of fraction, I'm going to times this side by the reciprocal. 5 over negative 1. Can you tell that's a 5? So 5 over negative 1, I times this side. So I kept that the same. I just took the reciprocal and put it on this side, basically. And then I know that's gone over there. Notice I did the negative. You've got to include that as well. Okay, multiply, and I get 35 over negative 10 equals x. Reduce that by dividing both of them by 5. So I know 5 will go into both of them because they end in 0 and 5. So divide the top by 5, I get 7. Divide the bottom by 5, I get negative 2. So that is what my final answer ends up being. Okay. Let's try one where the variable is written in the numerator. So we're going to do negative 9/40 equals negative 3u over 10. Okay. Okay, so this one, you may think, oh, I don't know what to do because the u's up top. Well, we can pull that u out to the side. Essentially, this is your coefficient, and that u is just hanging up there. The reason why is because, remember, that's 3 times u over 10. And the negative's out here as well. So if you notice, I could put my u over 1, right? And if I'm multiplying, what would be 3 times u? 3u. What would be 10 times 1 is 10. And my negative's still hanging out in front. So that's why you can pull it apart and just say, oh, I'm going to take the numbers and make it negative 3/10 times my u, or u over 1. In this case, I want it just to be u. Okay? So when you see it written together, it's really good to get in the habit of being able to pull apart fractions like that. Again, you can't just pull apart anything. It's when it's multiplying. So the 3 times the u, that's how I know that I can pull this away from the u. So I've got my 3/10. I'm going to pull it away from the u. And some people have a hard time visualizing it when it's still upstairs, so they just write it out to the side like that. Okay, remember, out to the side is essentially over 1. If we were to, anything's over 1, right? Like if I had some of the problems we did before, we had like 2/3 divided by 16. It looks like it's written level, right? But then when we put it over 1, the 16 went up to the numerator and your 1 was in your denominator. Okay. Just note, we're not going to get in what if the u is in the denominator, but note, u upstairs, or in the numerator, is the same as u out to the side. So 3/10 times u. But it wouldn't be the same if the u was down here Not the same. Not the same. Okay? So we aren't going to get into that. You'll probably get that when you get into 990. Okay, so here is where we're at. I've just pulled that out to the side. And now I go, oh, I've got a coefficient that's a fraction. I'm going to times this side by the reciprocal, 10 over 3, and it was a negative 10 over 3. And so now this is gone. So I do the multiplication here. Negative times a negative is a positive. 10 times 9, 90. 3 times 4, 120 equals u. Reduce your fraction. Oh yay, we've got zeros at the end. 3 goes into 9 3 times. 3 goes into 12 4 times. So u is 3/4. Oh, can you see it? Okay. Okay, that is it for 5.4. Let me give you your assignment. You are going to be doing 5.4. Let me see. You see it. 5.4. Where is it? You're doing 9 through 48 multiples of 3. Can you see that? 9 through 48 multiples of 3. So again, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, and 48. Okay, we'll see you next time. One more video. We'll see you next time.